You would consider something apart from the way it is in reality, because in order to have a science, it needs to be science. In order to know something, to have scientific knowledge in the traditional sense, is to know something that cannot be otherwise. And so you can't strictly know something about what's always changing, or you have the problem of Heraclitus, or you can never step into the same river twice. As soon as you know something about this, it's changed, and therefore what was true before is no longer true. And so actually all sciences to some extent separate themselves from the particular flux of reality, and the difference is the amount or the level at which they abstract from reality. So you really can't have knowledge of changing things, an unchanging knowledge or a stable knowledge of changing things without in some way abstracting from the fact that they're changing, if that makes sense.
Yeah, so why study geometry specifically?
Well, it's first. So geometry is the easiest discipline, but it's also a fundamental discipline. Maybe it's fundamental to other sciences. It can be known well or known at all before other sciences can, and not vice versa. So to just take maybe one line of scientific development, you say, without geometry, specifically Euclid's Elements, Ptolemy would have never been able to write his Almagest, which is the greatest, that's what it's called, the greatest work in astronomy in ancient times. But without Ptolemy and his use of geometry, you wouldn't have Copernicus and the Copernican revolution. And without Copernicus and Ptolemy, you wouldn't have Kepler's astronomy, or you wouldn't have Galileo's two new sciences. And without Galileo and Kepler, you couldn't have Newton and Newton's Principia. And without Newton's Principia, you couldn't have Einstein's relativity theory. So you can see, right, you don't get to Einstein without going through Euclid. It's a necessity. In a nutshell, St. Thomas says geometry is particularly proportioned to beginners, and believe it or not, it's because it's easy. So that's kind of counterintuitive. Most people think of mathematics as more difficult, and I think the reason why that is because it's more clear when you don't know the answer when you're doing mathematics, and so you think it's more difficult, but really it's an easier discipline. It's easier to see when you're wrong. If you do another discipline, it's more difficult to see when you're wrong. So it's because it's so simple, because it's considering things in such an abstract way, away from the changes of nature. Anyone can do it. It requires no prior knowledge. Anyone could pick up the elements, and if they reason carefully through the elements, they could understand it. And so that way it really forms the basis of a liberal education. And I might say finally, two things. It really prepares the mind and the student for the more difficult disciplines. Geometry, it exercises your memory, because you have to memorize the proofs. It exercises your reason because it is a proof, so it consists of proofs, and so you have to go through a line of reasoning that are clear and exacting, and where you can see the certitude easily, and all of the proofs have to be drawn back to your imagination, and so in that way it exercises your imagination. So it exercises three of the fundamental faculties of learning. We have this tendency, to make our opinions not simply based on the reasons for those opinions, but based on what we want to be the case, or what we have a habit of thinking of. So, what is the nature of the soul, or what is the nature of the good, or what's the best form of government, or does God exist? Those things are really tied up with our will, and we want certain answers to be the case. And so we could have a habit of developing conclusions that are based more not on the reasons given for them, but based on what we want to be the case. Whereas if students, I tend to think, don't have that sort of disposition of will one way or the other when it comes to the conclusions of geometry. So by studying geometry, they get in the habit of determining their opinions simply based on the reasons for them. And then when they go on to do these other disciplines, they're more disposed to consider them in that purely rational way.